Good morning, children. So we are going to continue with exercise 12.2. Here question number 5a, you can see it's given if x be real, find the minimum value of 3x square minus 6x plus 8. So we have to find its minimum value. What would be its minimum value? Okay, where x is real. So see the solution. For this, what you have to do is you will copy this quadratic function given 3x square minus 6x plus 8 and x belongs to real number. Now what you will do is you will write this 3x square minus 6x plus 8, and now if you see here 3 and here 6, so 3 is common, so you can take this out and leave it like this. Done. Now within this bracket you have x square minus 2x. Try to complete the square. Okay, so here I can write x square minus 2 into x into 1, and here I can write 1 plus 1 and minus 1. Okay, now if you see, this much can be written as x minus 1 whole square. Yes, so x minus 1 whole square and minus 1 and here plus 8. Now open the bracket, you get 3 times x minus 1 whole square minus 3 plus 8, and you get 3 here and here plus 5. So we are getting 3x square minus 6x plus 8 is equal to 3 times x minus 1 whole square plus this. Now we can easily decide for what value of x this whole thing will be minimum, okay, and what will be that minimum value. Okay, so here you can see this will be always positive. Yes, because we are taking a square. This is also positive, this is also positive. If you add positive numbers, yes, if two numbers, if you take two positive numbers and you add, obviously you will get more than, like 2 plus 3, you will get 5. Yes, this will be always greater than individuals. Yes or no? So here you can see plus 5 and here also positive number only. So when you can get this whole thing minimum, when this becomes 0, when this becomes 0. Okay, now when this will be 0, when x is equal to 1. Yes, so you can write 3x square minus 6x plus 8 will be minimum for x equal to 1. Okay, and what would be the minimum value? Means if you put x equal to 1, then what you will get? So this will become 0 and you will be left with only 5. Okay, so this will be minimum for x equal to 1, and the minimum value is equal to 5. This is the solution. Okay, now we will see question number B. So here it says if x be real, find the maximum value of a square plus 2ax minus x square. Solution. Given ax square, a square plus 2ax minus x square, and x is real. Now the same thing can be written as minus x square minus 2x minus ax square. Okay, x belongs to real number. Now I will try to complete the square. Okay, so I can write so here I am adding a square and subtracting a square. Okay, now this part can be written as x minus a whole square. So x minus a whole square, and here minus a square and minus a square becomes 2a square. And until here, so here we will get, or let us open the bracket. Okay, so here we'll get 2a square minus this. Now the question is, for what value of x this whole thing will be maximum. Okay, so here you can see that this will be always positive 2a square, and this x minus a whole square will be always positive. So from one positive you are subtracting another positive. Okay, let's say 4 is there and 2 is there. If you are subtracting, then obviously the number which you will get, let's say this is 6, the number which you will get will be small. Okay, you will get small number. Okay, like here you can see this 4 is smaller than 6. So when we'll have maximum? When this becomes 0. Okay, and when this will be 0? When x is equal to a. Clear? So you can write like this: a square plus 2ax minus x square will be maximum for x equal to a, and the maximum value equal to 2a square, because this part has to become 0 in order to make this whole thing maximum. Okay, so maximum value will be 2a square. Okay, so the next question is question number 12.1. So here it says find the range of values of x for which this is true. Okay, now they want you to find those values of x for which this inequality holds. Okay, now in class 10 we have learned that if we multiply or divide by a positive number, then this sign does not change its direction. Okay, but if we multiply by a negative or divide by a negative, then this direction will be changed. Okay, so see over here, given x square plus x plus 1 upon x square plus 2 less than equal to 1 by 3, and x belongs to real number. Okay, so here you can see in the denominator we have x square plus 2. Okay, Now no matter what value you take in place of x, this will be always positive, means greater than 0. Okay, so since this will be always greater than 0, so if I multiply both the side by x square plus 2, then this direction will not be affected. Yes, so in the next step I can take this, or you can say that I can multiply on the right with this x square plus 2, because this is a positive, so direction will not change. So I get x square plus x plus 1 less than equal to 1 by 3 x square plus 2, and this 3 is a positive number, you can multiply on left. So we get 3x square plus 3x plus 3 less than equal to x square plus 2. Now 3x square and this we can bring to the left with minus. Okay, and when you are adding or subtracting, direction does not change. So here 3x square minus x square, so you will get 2x square and plus 3x, and 3 minus 2 you get 1 less than 0. Okay, less than equal to 0. So here you can see that you are getting a quadratic equation. Okay, so you can do the middle term factorization. Okay, middle term is splitting in fact. So 2x square plus 2x plus x, so here we get 2x, x plus 1, and here 1 times x plus 1 less than equal to 0. So 2x plus 1 and here x plus 1 less than equal to 0. And once you have factorized, what you are supposed to do is, you should not have plus sign over here. Okay, you should keep minus over here. Okay, and in front of x means you should not have anything in front of x, means in coefficient, as coefficient of x you should have only 1. So I can take 2 common outside, so I'll get 2, and here I can write half like this. Yes, and this, as I said, I don't want plus over here, I want minus, so I can write like this, x minus minus 1 less than equal to 0. Okay, you can divide both sides by 2, so you get rid of this 2. Okay, and as I said, I don't want plus over here, so I can write like this. Done. Now what you will do, once you have reached till here, just beside this you will draw the number line. Okay, you draw the number line, and then see over here, one is minus half and one is minus 1. So here I can put minus half and here minus 1. Okay, now what you do is, you can make like this, and here you can see on the right of minus half we don't have any number written, so we will take this till here like this, will not join, just leave it like this, and this one like this. Okay, now see, here we saw that due to this minus 1 and minus half, okay, this number line got divided into 3 segments. Okay, like here is minus infinity, here it is plus infinity. So one segment is this, from minus 1 to minus infinity, one is minus 1 to minus half, one is minus half to this infinity. Okay, so now we have to check in which segment or which interval, you can say, like 3 intervals are there. So in which interval this is satisfied? Okay, so how to check that? So here you can see that 0 lies in this interval, 0 lies in this interval. Okay, 0 will be somewhere here, 0 lies in this interval. So you just replace x by 0. Okay, so if you replace x by 0, then what you are getting on the left hand side? Okay, so your left hand side I am writing here in rough. Okay, this is your left hand side. So in place of x you put 0, so you get 0 minus, and here this becomes, and here it becomes 0 plus 1. So you are getting half, which is greater than 0. So you are getting positive value, yes or no? So you'll write plus, you'll write plus over here. Okay, and once you came to know that in this interval this left hand side is giving you positive, so now you have to fill it alternatively. Okay, that means now this will be minus, then this will be plus. Okay, so you observe that for this interval -1 to -half, okay, this left hand side is coming negative, means less than 0. Okay, and for -1, okay, and for -1 this is exactly 0, and for -half it is exactly 0. Okay, so this is satisfied for -1 to this, it is satisfied for this interval. Okay, when I give this square bracket, means even -1 is included. Okay, but if I write like this, that means except -1 and -half, everything in between this. Okay, but in this case, since equal to is there, okay, so equal to 0 will get only when x is -1 and x is -half. Clear? So now you'll write, therefore x, okay, this x belongs to this interval. Okay, this is the answer. Or you could have also written in this way, or you could have also written this way, that your x is in between this. Okay, okay, now let us see the next question. So here we have to solve this. That means we are looking for the values of x for which this inequality holds. Okay, so solution: given x square plus 6x minus 11 upon x plus 3 is less than -1. Okay, and here x will be real number. Okay, x will be real number. Now here what do we observe is, on the left hand side, if you see the denominator, it is x plus 3. Now if you put x equal to -3, then this will become 0, and if you put like x less than -3, okay, then in that case this will be less than 0, negative. And if you put x greater than -3, then in that case this will be positive. Okay, so here what do we observe is that for some values of x, okay, for some real values this is 0, not for some, for -3 is 0, and for some it's positive, and for some it's negative. Okay, so since it's not positive all the time, so what we have to do is, we cannot multiply on the right with x plus 3. Okay, so and one more thing, that here x cannot be equal to minus 3. So we'll write let x not equal to minus 3. Done. Now x square plus 6x minus 11 upon this less than minus 1. Now as I said, this x plus 3, for some values it is positive and for some value it is negative. So I cannot multiply on the right with x plus 3. So for that what we have to do is, we will bring this minus 1 to the left. Okay. Now you have to simplify the left hand side. So you will get x square plus 6x minus 11, put this in bracket, plus 1 times x plus 3. Okay, so I get this, and denominator I am getting x plus 3 less than 0. So you get x square, and here plus 6x, and here plus x, you get plus 7x, minus 11 and plus 3, you get minus 8 upon x plus 3 less than 0. Okay. Now what we will do next is, here you can see the denominator, it is x plus 3. So I will multiply the numerator and denominator by x plus 3. Okay. And when I am multiplying and dividing by the same number, in that case this sign, this direction of this sign will not change. Okay. So we write x square plus 7x minus 8. We are multiplying this with x plus 3, and here x plus 3, x plus 3 less than 0. And down you are getting x plus 3 whole square less than 0, and our x is not equal to minus 3. So obviously this denominator cannot be 0 now. Yes, because we are not taking x equal to minus 3. We are not considering it. Okay. So obviously this will be always a positive number. Yes, and this cannot be 0. That means this part, the numerator part, is less than 0. Okay. So this implies that x square plus 7x minus 8 x plus 3 is less than 0. Now this is a quadratic expression, so we can factorize it. So I can write like this, and this can be written as x minus minus 3, and here we'll get x plus 8 minus 1 x plus 8. So x minus 1 x plus 8, and here x minus minus 3, so less than 0. Then here it's minus, good for us. Here is plus, we have to make it minus, so we can write done till here. So we have been able to factorize, and here you can see minus minus minus. Now we will draw the number line. This is the number line. Now we will write these numbers. Okay, so here we have 1 minus 8 and minus 3. So that means minus 8 will be here, then minus 3, and then 1. Okay, so because of these three, we are getting how many intervals? 1, 2, 3, 4 intervals. So now you can draw like this. Done. Now we have to check which interval is satisfying this. Okay, so it is always easy to take x 0. Okay, so 0 lies in this interval. Yes, 0 will be somewhere here. So on the left hand side, you, in place of x, you put 0. Okay, so on left, if you put in place of x 0, then what you will get? 0 minus 1, here 0 plus 8, and here 0 plus 3. So you are getting minus 1 into 8 into 3, so equal to minus 24, which is less than 0. Yes, so here you are getting negative. Okay, minus. So other intervals have to be filled alternatively. That means this will be plus, this will be plus, this will be minus. Okay, so here what did you observe? Okay, this is minus infinity and this is infinity. So here what did you observe? That these two intervals, one minus infinity to minus 8 and minus 3 to 1, these two intervals are satisfying this, okay, inequality. So we will write, this was rough, so I'll rub it. Okay, now you can write, therefore this x will be less than minus 8. Why I am writing only less than? Because here equal to sign is not there. Okay, so minus 8 is not included. So x is less than minus 8, or x has to lie in between minus 3 and 1. Done. So this is the answer. Okay, so for x less than minus 8 or x lying between minus 3 and 1, you will see that this given inequation, okay, this given inequation will always hold. This was the given inequation here. This will always hold for x less than minus 8 and for x lying between 1 and minus 3. Okay, so this is done. Okay children, now let us see the next question. This is not from your book. This had come in year 2019, okay, for 6 marks. So here it is saying find the range of x of the inequality. So that means we have to find the values for x, okay, for which this inequality will be true. So here you can see on the left hand side we have in the denominator 3x square minus 2x minus 5. This is a quadratic function. So firstly we have to see whether this is always positive or always negative, or for few or for some values it's positive and for some it's negative. Okay, we have to find that. If it is always positive, then good for us. Okay, otherwise we have to do it in different way. Okay, so see this solution given x square minus 2x plus 5 divided by 3x square minus 2x minus 5 greater than equal to half. So firstly, here in denominator we have 3x square minus 2x minus 5, okay, where a is equal to 3, b is equal to minus 2 and c is equal to minus 5. Clear? Then discriminant will be b square minus 4ac. So you'll get, so here actually I'm trying to find the sign of this quadratic function. So here b square means minus 2a square, that is 4, and minus 4a here and this. Clear? So we are getting 4 3s are 12 and 5s are 60. This is greater than 0. Okay. So as d is greater than 0, then 3x square minus 2x minus 5 is not always positive. Okay. It's not always positive. So it is not always positive. Okay, then what we have to do? We have to find the roots for this one. Okay, so let us find the roots. Now 3x square minus 2x minus 5. So here 3 5s are 15. Okay, so we can write 3x square minus 5x plus 3x minus 5. So we get 3x minus 5 here plus 1, 3x minus 5. So x plus 1 and here 3x minus this. So you can write like this, x plus 1, and this 3 can come out, so you can write over here, and x minus 5 by 3. Okay, so therefore roots are x equal to minus 1 and x equal to 5 by 3. So that means this quadratic function will be 0 for x equal to minus 1 and x equal to 5 by 3. Clear? So once we have got the roots, now we can proceed to find the values of x for which the inequality will hold. Okay, so now we'll write next we will copy that inequality. So this inequality is x square minus 2x, x square minus 2x plus 5, and here we have 3x square minus 2x minus 5, and this has to be greater than equal to half. So greater than equal to half, and x will be from real, but x will not be equal to minus 1 and x will not be equal to 5 by 3, because if x is minus 1 or 5 by 3, then denominator will become 0. Okay, and in that case this whole thing will not be defined. Now as we have found that this is not always positive, so we will not multiply the right hand side by this denominator. Okay, we will bring this right hand side to the left hand side. So we get x square minus 2x plus 5 upon 3x square minus 2x minus 5 minus half greater than equal to 0. Okay, then we'll simplify it. So we will get this x square minus 2x plus 5, 2 will be here, and here 1 time 3x square minus 2x minus 5, and here 2 times 3x square minus 2x minus 5 greater than equal to 0. Now we will simplify it. So 2x square minus 4x plus 10 minus 3x square plus 2x plus 5, and here in the denominator 2 times, and this quadratic function can be written as 3 times x plus 1 x minus 5 by 3 greater than equal to 0. Here 2x square minus 3x square, so you get minus x square minus 4x and plus 2x, you get minus 2x. Here plus 5, plus 10, and here plus 5, so you get plus 15. And down you are getting 6 x plus 1 x minus this greater than 0, greater than equal to 0. Now what we can do is we can multiply both the side by 6. Okay, so that I can get rid of this 6. Okay, so we will get minus x square minus 2x plus 15 upon x plus 1 x minus 5 by 3 greater than equal to 0. Then you can write minus x square plus 2x minus 15. Now in the numerator you have a quadratic expression, so try to factorize it. So here 1, here minus 15, so we can write like this, plus 5x minus 3x minus 15 x plus 1 x minus 5 by 3 greater than equal to 0. In the next step, okay, this minus sign is there. Suppose I want to remove this minus sign, then I have to multiply both the side by minus 1. Okay, so in that case this direction has to change. So I can write like this, x square plus 5x minus 3x minus 15 upon less than equal to 0, because I am multiplying both the side by minus 1. So whenever you are multiplying by negative number, direction has to change. Okay, and here in the numerator you are getting x plus 5 and here minus 3 x plus 5 and here x plus 1 x minus 5 by 3 less than equal to 0. Then you get x minus 3 x plus 5 divided by this. Now what we will do is, here x plus 1 and here x minus 5 by 3. So we will multiply by x plus 1 and divide also by x plus 1, and we will also multiply by x minus 5 by 3 and divide by x minus 5 by 3. So this step is important. So here I am multiplying and dividing by same. So in that case this will become x plus 1 whole square and this will become x minus 5 by 3 whole square less than equal to 0. Okay. Now here you see that denominator is going to be always positive. That means numerator has to be less than equal to 0. So I write this. Okay. Now x plus 5 we will write x minus minus 5. X plus 1 will write x minus minus 1. Done. Okay. Now we will take number line. So this is the number line. Here now we have to mark these numbers: 3, minus 5, minus 1 and 5 by 3. So okay, so minus 5 and here minus 5 by 3, here minus 1, then 3. Sorry, not minus 5 by 3, it has to be, one second, minus 1 and here it will be 5 by 3 and here 3. Okay. And one more thing, here we know that x belongs to real number and x is not equal to minus 1 and x is not equal to 5 by 3. So whenever we are drawing this, no, what we'll do is we will put like this. Okay, like this. That means this minus 1 and 5 by 3 not included. Clear? Okay. So we have got 1, 2, 3, 4, 5 intervals. One is this, second, third, fourth interval, and this is the fifth interval. Minus infinity, plus infinity. Now we have to check in which interval, okay, this is satisfied. So it's always better to check for x equal to 0. So let's say in left hand side wherever you have x, put x equal to 0. So we'll get minus 3, then here plus 5, then plus 1, then minus 5 by 3. So here it will become greater than 0. Okay, so 0 is in this interval. Okay, so this, for this interval you are getting positive. So the remaining intervals are to be filled alternatively. So this will be minus, this will be plus, this will be minus, this will be plus. Okay, but here we are looking for only those values of x where this left hand side has to be either 0 or less than 0. Okay, so you can see that this interval minus 5 to minus 1 where minus 1 is excluded, and 5 by 3 to 3 where 5 by 3 is excluded. Only these two intervals satisfy this. Okay, so now we can write therefore you can write like this: minus 5 less than equal to x less than minus 1. I'm not putting equal to sign because minus 1 is not included. Okay, or 5 by 3 less than x less than equal to 3, because 5 by 3 is not included. So this is the answer. So for x lying between this, okay, lying in this interval or in this interval, will satisfy this given inequality. So this is the answer. So this is all for today.